Hi, I'm Emma.
And I'm Sarah, and we are teaching lesson 4.3 on rational exponents.
So for number 1, the index is missing, and whenever the index is missing, you can assume that it's going to be 2. The number inside the radical, which is called the exponent, is also missing, and whenever it's missing, you can assume that it's going to be a 1. And then after that, you take the index and you put it under the exponent, making it 1/2. So the answer is 8 to the power of 1/2.
Okay, now for number 2, it's the same thing, except your index is already there, which is a 3. So you just take your index and you put it under the exponent. So your answer would be 5 to the power of 8 over 3.
In number 3, the index is 4 and it goes under the exponent, which is 3. So I'll write that. There we go. Then your radical sign cancels out, so the answer would be 3x to the power of 4 over 3.
Now for number 4 through 6, which is just the exact opposite of 1 through 3, so it's like you're working backwards. You take the exponent, which is 1 over 5, and you take the 5 and you move it outside of your base, which is 4, and you have to add a radical. So your answer would be 5 to the radical of 4, and it would be 1, but you don't have to draw the 1 in.
In number 5, 3 is the denominator, making it the index. So you're going to work backwards basically, and you're going to put 3 on the outside. So like that. While the numerator, which is 5, it is going to stay with the base because it's the exponent. So the answer is going to be 16 to the power of 5 with radical 3 on the outside.
Now for number 6, you just take the 4 and you put it outside of the base. And since the base is in parentheses, you don't have to do anything about it, you just leave it there. So your answer would be 4 would be your index, and you add the radical with 5x y to the power of 2, and which you put in parentheses, and then your 3, which is your exponent, stays on the outside. And now for number 7, which is evaluating this expression. So you just work it out like the problems before. So it would be 2 would be your index with a radical 4 and your exponent of 3. And you can now break the rational down. So it would be 4 to 2 and 4 to 1, because 2 plus 1 is 3. And your 2 for your index is still out here, so since you have a 2 out here and a 2 in here, you take a 4 out, and so it would be 4 radical 4, which is equal to 2 times 4, which then equals 8, which is your answer.
For number 8, you're going to separate the base from the exponent, so that's 9 and negative 1/2. So first off, 9 is just 3 to the power of 2. And you're going to multiply that by negative 1/2. When you multiply those two together, the denominator cancels out and you're left with negative 1. So your answer is going to be 3 negative 1. But you have to simplify it because you can't keep the negative exponent. So you put 3 over 1 and you bring the 3 down. And then your answer is going to be 1 over 3.
So for number 9, you're going to do 2 2 to the power of 3 because that equals 8. And then you're just going to keep your exponent the same. And then these cancel out, so you're left with 2 to the square root of 2, which equals 4. And there's your answer.
Just like in number 8, you want to separate the base from the exponents. So that's 32 and negative 3/5. To start, 32 is equal to 2 to the power of 5. And you're going to multiply that by the negative 3/5. The denominator is going to cancel out the 5, and you're left with the negative 3. So that's going to get simplified to 2 to the power of negative 3. But the exponent can't stay negative, so 2 minus 3. If you put the 2 over 1 and bring the 2 down, you'll get 1 over 2 to the power of 3, and that equals 1/8, and that's your answer.
So now with the rational exponents, there's laws and rules, and the first rule is xa times xb, and all you have to do is add the a and b together. So since your index, for the first example, since your index is 3, you just take the 3 out, and so it'd be 3 radical and be x to the 5th times x to the 4th. So then all you would do is add the 5 and the 4 together, and your answer would end in 3 to the square root of x, power of 9.
For the next one, you're going to keep the 4, so it'll stay on the outside, and then to the square root of a to the 3rd over a to the 5th. And that's going to get simplified down to square root of a 3 minus 5. The rule is that x stays the same and you subtract b from a. So that's why the 3 minus 5 is there. Next, all you have to do is simplify the numbers, so everything else stays the same. Your base stays the same, and then you just do 3 minus 5, which is negative 2. So since it's negative, we have to switch it like we did before, and that's going to equal 1 over 4 to the square root of a squared. And that'll be your answer.
Now for the third rule, all you have to do is multiply a times b. So for here, you can automatically assume there is a 1 inside the parentheses, since there is no other number there. So all you have to do is multiply your 1 times 4, and your radical carries over. So it would be radical, and then x, and 1 times 4, which is 4, and that's your answer. And for the last rule, since you have a negative up here, you have to switch it like in some of the previous problems. So it would be 1 over x to the 1/3, and then again over x, 1 over 3. And when adding fractions, you just do 1/3 plus 1 over 3 equals 2/3, because your denominator stays the same because you had to add those two together. So your final answer for this would be 1 over x, and your exponent would be 2 over 3. And now here are some example problems. So for the first one, it's a multiplication sign, but you have to add. So what you would do is your 5 would stay the same. So it would be 5, and then since you're adding fractions, your denominator is the same, so you just add the top, so it would be 5 and 4 over 4. 4 over 4 is equal to 1, so your answer would just be 5. And for the next problem, you have to apply the 6 to both of the powers. So it would first be 1 over 2 times 6, which equals 3. And then the 2 over 3 times 6 equals 4. So then you would have A3 and B4, which is your final answer.